Okay, next problem. Greg and Elmer are children. They're lying on the ground looking up at the sky. Before we go any further, let's just go ahead and draw it. Lying on the ground looking at the sky. There's somebody laying right here. There's Greg. There's Elmer. We'll put a G there because he's a G. We'll put an E there because he's Elmer. And they're looking up at the sky, and they gaze into a bird's nest on the top of a tree that is between them. So there's this tree in between them, and there's a bird's nest. And for reasons that I hope will become apparent, we're going to pretend like this bird's nest is just kind of hovering in the air. We got these beautiful little baby birds in here, and that does not look like a bird at all. Wow, I'm a terrible artist. Okay, anyway, there's birds, huge ones. There's some over there, and there's some over there. There's one there. Okay. Anyway, they're looking up at this bird's nest. And again, I know it's going to be in a tree. That was a crooked line. It's supposed to be a straight line. His line of sight's not very straight. Here we go. Okay, here it is. We have a triangle. And that was the whole point. Now, again, I realize there's a tree in the middle, and we will draw this tree in just a moment. But it is this triangle that we care about, not necessarily the one that involves the tree. That tends to confuse things a little bit. We're going to use that one on the next problem, but we're not going to deal with that right now. So let's erase the tree. Let's put the birds hovering in their nest above the ground. So it's important that you draw the picture appropriately. They're aligned 20 feet apart, and they gaze up into a bird's nest at the top of the tree between them. Greg looks up at an angle of 62 degrees. Angles go in the corner. Put a degree with it. Elmer looks up at an angle of 40 degrees. How far are Greg's eyes from the bird's nest? Okay, well, if this is Greg, because he's a G, and there's our bird's nest, we'll put a capital B there for birds. So, G, the distance from Greg to the bird's nest, that's what we're looking for. We'll call that little e because it's across from big E. Okay, so even though it's asking about Greg's distance from the bird's nest, it's going to be little e because it's across from big E. Now, we have to decide if we're going to use a law of sines or law of cosines. We will use the law of sines if we know an angle and the side across from it. So we don't know both of those. We don't know both of those. We don't know both of those. But before you give up on the law of sines, keep in mind that sometimes finding that third angle is very, very easy. Here it goes. 180 degrees in every triangle, and we know two of the angles. And there we go. We're going to get that very easily. Winds up with 78 degrees. That third angle is 78 degrees. While we're at it, we'll draw another bird. There we go. So, 78 degree angle up there. And now we know an angle and the side that's across from it. So we will use the law of sines. Again, make sure your calculator is set to degrees. So here we go. We're going to pair up an angle and the side across from it. So the sine of, in this case, big B, which would be 78, over little b, which is 20. We are looking for this one, so we're going to use that one. We go across. So sine of 40 over little e. We're going to cross multiply. Let me warn you, it's personal preference right here. When we cross multiply, if you want to go ahead and type that in the calculator, that is fine with me. Wonderful. It's great. However, when you do that, you're going to have a lot of decimals, and it's going to be easy to mess up if you round it off. Personal opinion, I'm going to wait. I'm not going to type these little individual things in the calculator yet. We'll do it at the end. So we're going to have 20 sine 40, cross multiply here, and that's equal to E sine 78. Okay, now in the process of solving for E, we would divide by the sine of 78. So we'll cancel those. We'll divide by the sine of 78. Doesn't cancel anything there, but that's okay. This right here is exactly what we're going to type in the calculator. I'll even put parentheses with it. So 20 sine, parentheses automatically pop up in the calculator, 40 over sine 78. We will type that in. Make sure you're in degrees. I've said that about 50 times already, but it's incredibly important. And there we go. We got it. E is equal to, I'm going to use two decimal places because it's just a good place to round, 13.14. There we go, 13.14. Okay, for the next question though, it says using the same information from the last problem, how tall is the tree? Well, let's put our tree back. Let's put that tree right there. We want to know how tall it is. You call it whatever you want. I'm going to call it X. Call it X. Call it T. Call it whatever. We want to know how tall that tree is. Now let's look at this and think about it logically. Let me take this clipboard and cover up part of the picture so we can see what we're really dealing with. We're going to go on an assumption, which is probably a safe assumption, that this tree makes a right angle with the ground and that it stands up perfectly straight. And I think it's safe to make that assumption. Knowing that, let's look at this and see what we need to do. We have a right triangle and we have another right triangle. So we can use right triangle trig now to find the height of this tree. But keep in mind that we have a little more information than we did a minute ago. We now know the length of this side. Elmer is 13.14 feet diagonal distance from the bird's nest. It's at the top of the tree. A very poorly drawn tree. Looks pretty pathetic, kind of like these birds over here. Big green bird shows up. Okay, so we're going to come over here and we're going to do some right triangle trig and draw it in blue. Here's our triangle. Just going to redraw it just so we can get a fresh perspective on it. Here's the tree. There's our right angle. There's 62 degrees. And there's 13.14. Now, I know what you're thinking. You're also thinking, well, isn't that 10? No. No, 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 no. That is not necessarily 10. This tree does not necessarily split that 20 in half. We don't know that. Actually, we know it doesn't. The reason it doesn't is because these angles aren't the same. So it is not a safe assumption to put that down there. We don't know that. Also, don't chop that 78 in half. This tree does not necessarily bisect, cut in half, that angle. That is not a safe assumption. Based on what we know, we have enough information to solve it without trying to figure this out or without trying to figure out that angle. So we don't even need that. We don't need that. So let's start labeling some stuff. We're going to label it based on the angle that we do know, other than the right angle. This angle is the one that's going to give us the basis for the rest of our perspective. Opposite this angle is the x, and this is the hypotenuse because it's across from the right angle. Looking at the things that you should hopefully have memorized by now. Sine of any angle, call it theta, is opposite over hypotenuse. So we're going to use that. Let's keep writing in red here. Sine of 62 is equal to opposite over hypotenuse. Always going to turn out real nice. Let's just go ahead and do it all in one step. X is equal to, let's multiply by that, put it in front, 13.14 sine 62. We'll type that in the calculator. We're about to find out the height of this tree. There we go. So Greg and Elmer, sorry, let's pronounce his name, are laying on either side of an 11.6 foot tall tree. It was 0.60, but drop that zero off.